over to system invariants. And what's the difference about here? These are programs that run forever. And but still, when you start, you have to establish them, right? And right, so then what were various, if we want to do a stack, then this is a nice picture, right? And then, you push somebody in, right? If you want to do a queue, this is a nice picture. So you can go around and round, right? Everybody buy that? Right, so this says, well, you're not coding here. On the exam, maybe you'll code, but on the exam, when you have to code, you can think, well, I draw a picture of where I am now and where I want to be and how to get from one to the other, right? But you're not doing that on this test. Why? Because it's multiple choice. All right. Right. Everybody kind of get these sort of things. Oh, here's a funny thing. Suppose I have a pointer to the first guy in a linked list, and a pointer to the last one, and it's singly linked list, right? So adding and removing from the front is fast, right? Adding to the end is fast, right? But what about this guy here? If I want to remove this last node, what's the problem? Well, the picture has last pointing at the last one. And if I remove the last one, then the picture needs to have last pointing at the second last one, right? And how do I find the second last one? I have to walk there, right? So you should know that. Right, so here you can do, with this you can do a stack, and with this you can do a queue, right? You just avoid that one. Doubly linked list, you can do everything in constant, back both ends. How do you walk down a list? I like 2 fingers. I move my 2 fingers down until I surround where my spot